my god, that's,
Fertilizer with
that is
gas,
like,
and then travel some distance and buy a bunch of
I put a new
diesel
eraser on
with
yesterday.
gas.
Yeah.
So I
You get a little bit of
I put a new one on.
You know, some sugar.
I've had these same erasers
And you know
since
what the nice thing is?
when I got
You
this
can
one.
wear
Alright.
masks.
No, my other one's just a nub now. It doesn't, I can't really see it.
Any questions from homework, from fractions you're doing,
I
from
feel like you have to start homework to have questions on
It was
homework.
so bad.
anything? Don't ask me
What are your thoughts on those
the
curves?
mathematics you need to finish out your equal terrorism plans.
Oh no.
Sorry.
Do you have that knowledge?
Probably.
Oh my god.
Some light chemistry.
I just need the projectiles.
It's just-
even
we get
ground.
stuff.
Some light, some light to
It's
that.
all for the-
Where it's gonna land.
All right, guys. Any questions? Yes.
The one I asked.
The one you asked. Okay, we'll get to that when I do the lecture. Okay.
I'm still a little bit confused on 21.
21.
Yeah, and Carmen was gonna have 21.
Okay. All right. Let's do 21.
Oh yeah.
Yeah.
Problem?
Talk about this in a minute.
Is it in the homework?
Don't worry about this. We'll talk about this here in a minute. It's a little something I was trying to do last time. Let's see, how are you doing? Yeah, that's good.
What is this?
Sort of. So 21 does this. 1 minus 2 factorial over 1 times 3 plus 3 factorial over 1 times 3 times 5. Plus negative 1 to the n, what, minus 1?
Yes.
Times. All right, let's talk about the bottom real quick, because the bottom is weird. It isn't really that weird. We developed a shorthand way to say 1 times 2 times 3 times 4 times 5 times 6 times 7, right? We developed shorthand for that, yes? What is it?
N factorial.
Yeah, 7 factorial in this case, right? This is sort of a factorial, but it's a factorial that's very exclusive. What's the only kind of numbers it wants to consider? So we don't really have a way. We could. This class could make up a symbol that means only the odd numbers.
Should it be a question mark?
Huh? Question mark? Yeah, some other punctuation, right? The colon could be the even numbers.
Semicolon.
Semicolon, yeah, okay. So everybody kind of see that. So there's no way to truncate what the bottom is trying to say, right? But there is a way to truncate 1 times the next times the next, and that's why the top can be written, bam, very quickly. The bottom, they just have to write all the elements out, because there's no symbol we formulated to mean multiply all the odd numbers, right? You guys see that? So it isn't different, it's just unfortunate. Poor little thing. It never got to get its own symbol. So again, this is a total side note, but we could completely make up, like this means, this would mean, let's say, 8 times 6 times 4 times 2. Just all the even numbers down to 2. Are you guys with me? It didn't happen, right? But it could have. Okay, we're not gonna develop a new symbol and try to give it to the Mathematical Association American. We totally could, but let's not do that yet, right now. I just want you to understand what this is saying. It's nothing different than the top, it just doesn't have a symbol to represent all this stuff together. Does that make sense? Okay, so the next element, so this is AN. They were being very nice. They didn't make you come up with your own, even though you should be able to. They gave it to you. And real quick, how do you represent an even number? 2n. So what's an odd number? Or 2n plus 1, right? So that's why that makes sense, because I'm only using odd numbers. That's the way to represent a general odd number, with n starting at 1. Okay.
Is that 2n minus 1 factorial?
No,
Or, oh no, because you're only multiplying by the odd.
because 2n minus factorial is defined to go down by 1. I would need something defined to go down by 2. I like it. There's no generally accepted. notation, but I'm sure there's many mathematicians who have their own notation that means that. Because it does happen often enough, to be honest, it needs its own. Okay. And this says use the ratio test, right?
Yes.
Yes.
Yes. And even if it didn't say that, if I see a bunch of stuff multiply, if I see a bunch of stuff I wish would cancel, I think ratio test. Because it's gonna a bunch of shit's gonna cancel. That's the whole idea behind it. That's why it works really well with n to the nth or factorial stuff, because a lot of stuff will cancel. Okay. What is an plus 1?
N plus 1 times n factorial.
Well, okay, n plus 1 factorial, right? Let's just say -1, and we'll take the -1 off in a minute.
Over 2n plus 1.
Nope.
Oh, over,
You do not lose. Every element has the previous thing still on there times the next odd number. So an plus 1 is going to have all these elements on it times the next odd number, which you can get two different ways. The next odd number would be 2 up, right? And what's 2 up from 2n minus 1?
2n plus 1.
Or you can just replace 2n minus 1. You can replace the n with n plus 1. What's twice n plus 1? That's right, kids. And then 2n plus 1, right? So I get the same stupid answer either way. Does everybody see why all this stuff is here? Because that's the definition of every element. It's got everything that came before it times the next thing. So does the top. Doesn't the top have this in it? Did I just multiply by the next element? Yes.
For the 1, 3, and 5, like, why do we have to include it if 2n minus 1 is what those are?
Okay.
Because if we do that, they're
So
still covered in the.
All right. So if you thought an plus 1 was this, right? If you thought it was this, are you with me? Or I guess you'd think this?
Mhm.
Okay. Let's check it. So this is A1, this is A2, let's try A3. To get A3, what would n have to be? 2. So it's A3, -1 squared, 2 plus 1, 3 factorial, over 5. Is that what A3 is? Nope, what's it missing? The things from the previous term. So every term has all the shit in it from the previous term times the next dude. So it can't just be that, because then it doesn't follow the rule, right? No? And again, that's exactly what we did here. I think you said it. If I multiply n factorial by n plus 1, what do I get? N plus 1 factorial, right? Right? So we just multiplied what was there by the next thing. Of course I'm going to do the same thing to the bottom because it's defined in exactly the same way. It just doesn't get its own little special punctuation. Poor little dude. No? What is the top really? What is this really? 1 times 2 times 3 times 4, ... times n. So I could say that, and then this would be 1 times 2 times 3 and 4, ... times n plus 1. Exactly the way we had to do this one. Okay. So whatever you write down for a n plus 1, it better have the same form as every other element does. It can't suddenly go, nah, I'm tired of that shit. Right? It's got to follow the same rule. Thank God it does, because now, what do I want to do? I want to do the absolute value of this and take the limit, right? There's a lot of shit going on the board, I'm sorry. So this will be absolute value. I can just kill this. That's something to get really used to.
Yeah.
When you're doing absolute convergence stuff, you can just kill the negative part.
If that was -9, would that just become 9?
Yeah, yeah.
So that still exists, it's just not.
It's just the negative goes away, because I'm taking an absolute value, right? Okay. Okay.
So n plus 1 factorial over all that
So
stuff.
times, right, because we're going to divide by an, so we're going to multiply by the reciprocal. And you guys see how all this is going to cancel? Okay, that's all I'm going to do. That's it. Done with that. Is that enough, though? Who asked that question? Is that okay?
Yeah, that's good.
Okay.
Okay.
Are you good? Sorry. Okay, I'm gonna assume that's good enough. Okay. All right. Anything else from homework stuff or? Yes.
I don't know if it's like too late in the chapter, but number 50,
Number what? Sorry.
50 or 44?
Let's see.
I think it's 44.
44. I can barely see that. Oh, okay.
Yeah, 44.
For which positive image case the points just converge? Oh, okay. Yeah, let's look at that one. That looks cool. All right. It's going away. If only somebody was recording this, you could go back and look at it. Oh, yeah. New ones of these. Okay.
One question before you fully erase that.
Okay.
Well, it's filling now, but whatever. When you put them over each other,
Yes.
and you have n plus 1 factorial, pretty much,
Over n
over n factorial, how do you
Yep.
cancel that? Is that just n plus 1 on top?
Yeah, because n plus 1 factorial is n plus 1
Times n.
times n times,
So
So if it was over n factorial,
It'll cancel out the.
Awesome.
yeah. Okay. Alright, 44, yeah, look at this nifty little dude. N factorial squared, now we are discussing things. Yeah, alright, Jeff, well then. N factorial. Let me just ask you, what do you think, so the question is, what values of k make this converge? What do you think if I made k 1? Would it converge?
No.
Why not?
Because it's just the same thing.
It'd just be n factorial squared over n factorial,
Which is n factorial, which obviously goes to infinity,
Yeah.
right? So pretty much k's definitely gotta be at least greater than 1, maybe greater than 2, maybe greater than 10, I don't know, we gotta figure it out. You guys semi with me?
Could you, when you do that, can you break up the bottom to k factorial, n factorial?
No. Nope. And I really want this to make sense. Real quick. So if I had k n factorial, let's say that I have, let's make it more concrete. 5n factorial, right? And I think I'm out of this guy, let me do it over here.
You're good actually right
Sounds
now.
good?
Yeah.
If n is 1, I'm sorry. Yeah, if n is 1. What do we get? Actually, make this 2, sorry. So it'll be 10 times 9 times 8 times 7 times 1, right? Because it'll be 10 factorial. What if I had 5 factorial n factorial? And n is 2.
2 times.
5 times 4 times 3 times 2 times 1. This is always that times 2 times 1. Are these the same thing? No.
4, no.
So factorial is not distributive, which should make sense because it's fundamentally based on multiplication, not addition. It doesn't distribute across itself. It's not, you can't distribute it. But it's not a bad question to ask. I mean, factorial is relatively new to us. We don't necessarily immediately know the algebra of factorials, right? Okay. But it doesn't work that way. Good question. So, this sounds like it's a different process. No, it's the same freaking process. What do I do to see when this converges? What do I do to see if this converges? What's a good test to use? Ratio, totally, because it's got a bunch of factorial shit, right? So that'd be the limit, n goes infinity, n plus 1 factorial squared over, what happens in here? Is that cool? I replace n with n plus 1. Don't just add 1. Don't just say it's kn plus 1. No, you have to replace n with n plus 1.
For the numerator, could you just do n factorial squared? Do you really need the parentheses?
Oh, sort of, because
I feel like it's a practice thing.
it's like you're squaring the exclamation mark if you don't put parentheses. But technically, that doesn't mean anything, so yeah. Okay, so we're just being extra careful. Okay, so that's an plus 1, is that cool? then divided by, so times the reciprocal of this stuff. I love this problem. What, Jeff?
Do you, can you distribute the K in there?
Yeah, good, yes.
Cancel the K.
What is this?
That's gonna be
K
There's
in.
quite a few pieces of this that are just weird, right? This is kn plus k
Mhm.
factorial. What's over here?
Kn factorial.
Kn factorial. What do I normally try to do? I normally try to take the bigger one and pull enough terms off so that something will cancel, right? How many terms of this do I have to pull off?
Okay.
Say it, say it.
Okay.
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 Okay, yes, okay. So, do you guys, so for example, if I pull off one kn plus k, then there's a kn plus k minus 1 left, right? So I have to pull off kn plus k minus 1. I have to do that k times. Because then what would be left? Kn factorial. Like if it was n plus 2, and there was an n factorial, n plus 2 factorial, n plus, I'd have to do n plus 2, n plus 1. You do it twice, don't I? And then what's left cancels. Are you guys with me? You guys understand what I'm saying? If I had an n plus 2 factorial and an n factorial, wouldn't I have to pull off 2 of these? So that, you see what I mean by pull off 2? Bam! So of course how many of these do I have to pull off? K of them. And already you're like, ooh, I love this problem. Freaking K of them? What the shit are you talking about? What would that look like? Can anybody tell me? So is this, these cancel, right? Can you tell me what the degree of this?
K.
Good.
Make me.
There's KNs multiplying each other. Right? So then you get n to the K. So it's why is that important? Because of this guy. It should be K there, but
What?
what's happening?
But how can you make K?
Oh, I'm sorry, not K. I forgot, that's not K. There.
So many K's.
Too many things happening. That's a kth degree thing, right? It's like n to the k.
K?
And the fact that I'm taking a limit is important then. Because, so how do I give a clue? This should be plenty to more than get started, because I've gotten way started. So I'm gonna say one more thing. I mean, what do you do with these?
Can you cancel? Cause
What is this?
n plus 1 factorial squared, which is just,
So it's n plus 1 factorial times n plus 1 factorial, right?
mhm.
And you got basically over n factorial n. So each one of these, you can pull in n plus 1, n plus 1. Okay, right? That's all I'm gonna say. That's it. That is it. Okay. So if there's no more questions, I want to immediately, well, let's do this. I want to talk about root tests. We'll do that one problem. Oh shit, I want to do my thing. Somebody got what they want from this?
Oh.
I've got it here.
What happened?
Oh, thank you.
Are those supposed to be
Yeah,
like
listen.
ghosts?
That's funny.
I couldn't tell if it's like an onion or a ghost.
Like right as she said no, you just erased what you wanted.
I
Well,
forget.
you said no after I started.
Onion. I
Alright.
just look up and it's all gone. I'm all, oh,
You gotta listen.
sorry.
Like, have you seen
It'll
that
be
little
okay.
Pixar animation where like
So-
the dumpling comes alive?
No.
This is what I was trying to create, like on the fly last time. I made a little bit better one, but I want you to see how this is 1.
Yeah.
Then I multiply that by 1/4 plus 1 to get the next term, yes?
Okay.
And then I multiply that by 1/4 plus 0.1 to get the next term. Then I multiplied that by 1/4 plus 0.01 to get the next term. Sure, yeah.
So that's 1/4 plus 10 to the negative n.
Okay, we're getting somewhere. So then, in general, be careful though. In general, dot, 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 1/4 plus 1, 1/4 plus 0.1, 1/4 plus 0.01, dot, 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 1/4 plus, when n is 1, this is 1, when n is 2, this is 0.1, right?
So, yeah,
So it's like 1/10 to the, not this, right? Because when n is 1, it's supposed to be,
Oh, then
actually,
minus
when
one
n is
n
1,
minus
it's
one.
there. Let me make this a little better. This is too much to get into. I just wanted a nice thing just to show you. I really want you to see, if it was a geometric series, where r is 1/4, every time I do this, I would multiply by 1/4, correct? But I'm multiplying by something that is getting closer to what?
0.
No.
1/4?
1/4. Sure, this piece is getting closer to 0, which means this is getting closer to 1/4. So it's never geometric,
But it's almost geometric.
but it gets close enough, which is what the ratio test shows me. It's not geometric. I can't do a straight geometric on it. But let me see if we can get this. What did I do? Yeah. Nah. So it'd be n minus.
Yeah.
It's like
Just
just meh.
Yeah.
There you go. There's 1, 0, sort of, not really. Yeah, sort of. Sure, it's almost there. I almost got this. So yeah, all right, let's pretend like that's what it is. So I'm doing times 1/4 plus 1/10 to the n minus 1. Sure, that's roughly almost what it is. This is too much already. Sorry. So if I do the yes,
So where does the first one come from then?
this is where it starts.
Okay.
Yeah, and then I start multiplying by 1/4 plus whatever.
Okay.
So is this like what's it called? A function that uses, what is it, the other old parts of itself back into it? What's that called again?
Oh, recursive?
Yes.
That's sort of like what a geometric is, because it just keeps multiplying by the same thing. So it sort of is based on its previous thing, but again, to be a recursive sequence, you'd have to actually have explicitly in the form an equals an plus 1 minus an, you'd have to have it directly related to the previous elements. And I don't. Here's an right here. Right?
Oh,
Okay. So it does sort of, because it carries everything from before it with it. Okay, so an is this, yes? An plus 1, real quick, do this for me. This is 1. This is 5/4, that's amazing. This is 5/4 times 1/4 plus 1/10, right? Jeff, you're already taking up too much time. I just want to get there. I really want you guys. So this is 5/16 plus 1/8, 2/16. That's 7/16. Yes.
Yeah?
Okay. And this, oh shit, would be, isn't this 7/16? Okay. Times 1/4 plus 1/100. Whatever the hell that is. Okay. This is already so freaking exciting, John. I did this somewhere. Here. Where'd you go?
52 100ths
I thought I did it
in the
somewhere.
inside.
Gave up on it. No, there it is. 182 over 1600.
Yeah, because then you have to.
All right, now watch this. What's this divided by the term before it?
1/4.
No,
No. It's the same number that's gonna have, yeah.
it's close to 1/4. But what is it? Can somebody just do it? Do you have a calculator? Can you guys do that for me? By the way, everything I'm doing right now is side stuff. But I really want you to see a more concrete example of a function, of a sequence that's almost geometric. This is very clearly almost geometric.
6.
0.26, right? Which is almost 0.25.
Yeah.
Okay. So it's getting closer and closer to that. So if I actually do let me see if you guys can do this. Let's see. Limit as n goes to infinity of this. All right, I swear, I'll stop in a minute. So times the next one. Yes, that's an plus 1 divided by an. This all cancels. And what's the limit as n goes to infinity of this? This goes to 0, because it's a geometric, right? But it's 1/10 to n goes to 0, so you get 1/4. It's never 1/4. But it's close enough to 1/4 that eventually it definitely becomes a geometric. It just becomes a geometric. So as long as that thing you are multiplying by has a limit that is less than 1, it's basically geometric. Yes?
So as a sequence, this is convergent, but as a series, this is divergent?
No, this is totally, what happened? This is totally convergent, right?
But you're going to be adding 1/4 to itself, no?
No.
Because it gets
Oh,
tiny.
because
and
you're-
This is this,
I
this
see.
is this,
I
this
get-
is this times this. So it's getting smaller. Isn't that much smaller than this?
It just converges at 1.
Yeah.
Okay.
This was too much, I'm sorry. I just really wanted to show you. The ratio test is intimately related to the geometric series because that's what it's telling us. If I take the limit and I get something less than 1, it's telling me I'm eventually multiplying by something really close to this. So as long as it's less than 1, it's acting like a geometric. So that's why the result of the ratio test, if it's less than 1, it converges. Same way a geometric. If r is less than 1, it converges. Why? They both do that for the same reason. Okay. I think for students in 280, you learn these tests and you have to memorize the results. And oh my God, if you could just relate it to something we've already done, so you're not like memorizing two separate things. These are the same thing. Ratio test is geometric. They're the same thing. I really want to create something concrete where you can see that. I've got to workshop this some more. Okay. It just took too long to get to the payoff. Okay. So let's look at, well, all right. Let's talk about the root test. Oh, and let me actually start with this. That is very blatantly what?
Geometry.
Yeah, geometric. Is it convergent or not?
Yeah.
It's convergent. Do you see how taking the nth root of it would do something for me?
It would get rid of that power n.
If I take the nth root, and I'm going to take an absolute value just because that's what we do in general, just to be safe. What is the nth root of something to the nth power?
Itself.
So the same way that the ratio test is taking a ratio, it's amazing, right? Didn't expect that, to tell me if the next term is a multiple of the previous term, right? The ratio test is fundamentally saying, is this a multiple of this in the long term, right? So if I get 1/4, that means that the next element is basically 1/4 the previous, which is just like a geometric, which is why this would mean it converges, right? This one does even more direct. It says, no, let's not screw around with dividing shit. Let's just take the nth frickin' root, right? If I multiply 1/4 by itself 7 times, and I take the 7th root, I'm going to get 1/4. So I'm kind of uncovering what the multiple was very directly. So the nth root, the root test, is again related to geometric, right? Because what does geometric fundamentally look like? Does it look like constants to an nth power? I love it. So what good is the root test then if we already know how to handle it? Well, because we don't know how to handle variable expressions to the nth power very well, right? Maybe? No? Yes? Or do you? If you do, okay, great. Okay. So, let's try an example. Let's try that one. Number 27, sure. Is it 1?
2
2, okay.
minus 1
Minus 1, thank you.
over ln n to the n.
Okay, look at that. You see how it's trying to be geometric, but it's not a constant inside? Okay, okay. So that's what the ratio test and the root test do for us. When it's not a constant that I'm multiplying by, then I can kind of apply one of those tests to see, is that thing I'm multiplying by eventually becoming a constant that's less than 1? Then it converges. This is an. What's the absolute value of an? Let's do this one step at a time. Yeah, 1 over ln n to the n. Linen. Okay. Linen. Linen. Okay. So what's the nth root of the absolute value of an?
1.
What?
No.
What?
1 over ln to the n.
Yeah, don't the nth roots, what's the nth root of 1?
And 1.
1.
Is
Any
that
root of 1 is 1. And what's the nth root of this to the nth power? Linen. Okay.
Linen.
I can't remember that one.
Are we good? So then the actual test is the limit as n goes to infinity of the nth root of the absolute value of the thing I'm looking at, the series I'm looking at. So this will be the limit as n goes to infinity of
1
this.
over ln to the
And that is,
0. So
0.
convergent.
is that less than 1?
Yes.
Yes.
So absolutely convergent.
Absolutely convergent. So that is another little thing to say, ratio and root test, since they have absolute values built into them, the results mean if they're convergent, they're absolutely convergent.
Because you can have something like an alternating, there was one actually earlier in 11.6 where it was an alternating series that was conditionally convergent.
Wait, let me think. An alternating series.
Oh yeah, number 1.
It was,
Yeah.
Number 1 was conditionally convergent and alternating series.
Where are we at, sorry?
on 11.6.
11.6.
Or number 3 now.
Number
20, 21 as well.
Sure, yeah, okay, great. What do you mean? What's the problem?
Oh, it was just, it wasn't, it was,
Are you concerned because it wasn't absolutely?
yeah, well, I was before,
Okay,
but it's not a big
so,
deal.
real quick. What's the ratio test? It's the limit as n goes to infinity of what? Absolute value of an over an plus 1 over an, right? What's the root test? The limit as n goes to infinity of the nth root of? Absolute value of a. So, if you succeed with these tests, they have absolute values built in, so they are absolutely convergent then if they succeed. If you are applying some other test, it could be conditional, it could be whatever, yeah. Yes?
So if something diverges with this test, does that mean it's
It's just divergent.
just divergent?
Yes.
It can't be conditionally
If I
convergent.
get greater than 1 there, it is divergent, nothing can save it.
And if you get exactly 1, then you have to go back
Inconclusive, you have to use a different test.
Okay.
Yes.
For the absolute value test though, let's say we have an alternating series, can we go straight to absolute value test and see if the absolute value of AN is convergent, and then that'll tell us if.
Oh, alright, so let me do this. Okay. So we got this here? No? Okay. So watch this. Let's try to apply the ratio test to this. Yeah? Let's do it. This is sort of related to your questions, I believe. We'll see. Let's try to apply the ratio test to this, right? Let's see what happens. Because you have a very good question. It doesn't seem that the ratio and root test show you when things might be conditionally convergent, right? Okay, so let me show you an example of what's gonna happen. Can anybody tell me right now, will this be absolutely convergent? Absolutely convergent. If I take the negative one away, it's trying to be what kind of thing? 1 over n, harmonic divergence, right? So, but does it converge if I leave the negative 1 in? Shit, yes. It's decreasing, it's, well, if I'm more careful, it's positive. Make that a +7, sorry. Okay. So, but let's just try it. Let's see what the ratio test does. Yes? How are we doing? So an is this, right, without the negative 1. So an is this. What's an plus 1?
1 over 4 n plus 1 plus n.
Yes, so be careful. Do you understand this is not right?
Yeah.
Hell no. Right, same way that when you first did derivatives, f of x plus h, you can't just add an h to the end. Even though that's what everybody tried to do when you first learned it. So we gotta be better than that shit. So then we gotta replace n with n plus 1. So that's 1 over 4n plus 4 plus 7, 4n plus 11. Maybe? Okay, okay. Yes? N equals 2. Why? Oh, I made it a plus 7. I don't know.
Put a power on the top.
Oh, that doesn't matter. Why would that matter? What's negative 1 to the 0? 1. Yeah, you're good though, thank you. Please check, because like I said, I had it wrong up there to begin with, so I made it a plus 1. Okay, and by the way, these are absolute values, because I don't want to care about that, because I'm going to do the ratio test, right? So that'll be 1 over 4n plus 11. I don't want to do that, because I'm going to do times the reciprocal of this, right? What is that limit?
1.
Huh? Sorry. That was a neat reaction. I haven't made that noise before. Yeah, it'll be 1, which officially, what's the ratio test say?
Inconclusive.
Okay. Right? Sorry. Got you. Very sorry.
Got it.
In fact, that's gonna work for any p-series. It's gonna work the same way. Can you see that? If I make this squared, wouldn't, I mean, there'd be other shit, but wouldn't there basically be a squared and a squared?
Yeah.
Limit would still be 1. Inconclusive. Right? So any p-series type stuff, not only would there be better ways to do it, like, I don't know, just p-series, but the ratio test wouldn't even know what to do with it.
Yeah.
So that's why I try to say ratio test is good if I see factorials and I see nth powers. And the root test is if everything is to an nth power. Then you just take an nth root and kill that shit, right? Yes?
So now that we've introduced absolute value convergence, or testing to see if it's convergent by absolute value,
Yeah.
should alternating series tests be our like last resort now?
Anything, I would check to see if it's absolutely convergent first.
Yeah.
Because if it is, I'm done. If it isn't, then I worry about conditional, right?
Okay.
Because it would suck if you do conditional first and it works, you still have to do absolute.
Yeah.
If you do conditional first and it doesn't work, you still have to do absolute. Do you see what I'm saying? So you kind of cut your work if you do the absolute first, because sometimes that's all you got to do.
Okay. So if you just ask if it converges, not if it absolutely or conditionally converges, could we use the
Yes.
either test?
Yes, totally. If I ask, does it converge? The ratio and root test still tells you if it converges. It just actually tells you if it also absolutely converges. If the result is 1, then maybe it's conditionally convergent.
Yeah.
So that was your question. I want to see you show it to you in action.
Yeah.
It'll always be 1 if it's something that could be conditionally convergent.
Okay.
Yeah. That's what the ratio test will do for us. Okay. Made. Okay. She's gotten used to being looked at like I'm insane. Okay. Don't worry, I've got some more practice problems with absolute and conditional convergence, more practice problems with ratio tests. Let me just do a root test thing. I'll give you this. We'll try some example problems out. And then we'll see what was that? For a moment. I thought we were gonna need an exorcist. I don't know what was happening. I thought something was coming from the ground. I didn't know. Just for the moment. Alright. I watch way too many horror movies. I think I want to share a story with you real quick. I used to wear this puka shell necklace, believe it or not. I used to have a necklace. So I was taking a shower and the thing broke, I didn't realize, and it started to come off. And I saw it, and for a split moment I thought there's some alien behind me. Saliva, alien saliva. For just like 0.3 of a millisecond, I thought, yep. And then I realized, oh, it's that. Oh, it's a very strange place to
Oh
be.
my God.
Anyway,
Yep.
I'm sorry. Okay.
They just accept
He's in the shower with the
Okay,
alien.
that's good. You got me. Enjoy. I hope you choke on me. All right.
Wow.
So. All right. 27. No, that's the one we just did, right?
Yeah.
Oh, okay. So we're ready for this. Okay.
Ready for what? I'm confused.
For this little worksheet.
Oh, pop quiz?
Yeah, a little pop.
Don't you dare.
Oh, no root
This
test?
isn't Lance.
We just
I
did.
hope.
No, I decided no. We got
I hope
someone
you
here.
choke on me. Okay.
3, 4, 5, 6, 7. There's 7 problems on here. I would like you guys to try. Feel free to work together or not. It's up to you.
No.
Humbly request that you keep it down. The dull roar. You're working together.
Yeah, like a workshop.
Don't worry, well, I got you. I got both of you guys. Huh?
You gotta get going.
Oh, okay.
I will join you in a second.
He said personally, I don't like